Interrupts and atomicity. An interrupt is a mechanism for pausing execution of whatever a processor is currently doing and executing a predefined code sequence called an interrupt service routine, or an ISR, or interrupt handler. Interrupts are handled by a bit of logic in the processor called an interrupt controller. It supports some number of interrupts and some number of priority levels. Each interrupt has an interrupt vector, which is the address of an ISR or an index into an array called the interrupt vector table that contains all the addresses of all the ISRs. The response to an interrupt request might be level triggered, which means that the hardware asserting the interrupt will typically hold the voltage on the line until it gets an acknowledgement, which indicates that the interrupt is being handled, or edge-triggered interrupts, where hardware asserting the interrupt changes the voltage only for a short time. Three kinds of events may trigger an interrupt. One is a hardware interrupt, where some external hardware changes the voltage level on an interrupt request line. In the case of an software interrupt, the program that is executing triggers the interrupt by executing a special instruction or by writing to a memory mapped register. A third variant is called an exception, where the interrupt is triggered by internal hardware that detects a fault, such as a segmentation fault. For the first two variants, once the ISR completes, the program that was interrupted resumes where it left off. In case of an exception, once the ISR has completed the interrupt, the program that triggered the exception is not normally resumed. Instead, the program counter is set to some fixed location for where, for example, the operating system may terminate the offending program. Upon the occurrence of an interrupt trigger, the hardware must first decide whether to respond. If the interrupts are disabled, it will not. Moreover, it may be that some interrupts are enabled while others are not. Interrupts and exceptions generally have priorities, and higher level priorities will be serviced first. Typically, exceptions have the highest priority and are always serviced. When the hardware decides to service an interrupt, it will usually first disable interrupts, push the current program into program counter and processor status registers onto the stack and branch to a designated address that will normally contain a jump to an ISR. The ISR must store on the stack the values currently in any registers it will use, and after the execution of the interrupt, restore their values before returning from the interrupt, so that the interrupted program can resume where it left off. Atomicity. An interrupt service routine can be invoked between any two instructions of the main program. One of the major challenges for embedded software designers is that reasoning about the possible interleavings mixed signals of instructions can be extremely difficult. For example, the ISR and the main program can interact through a shared variable, like for the example in the code shown on the screen, where the shared variable is called timer count. The value of that variable can change between any two atomic operations of the main program. Unfortunately, it can be quite difficult to know what operations are atomic. It is far from obvious to a programmer what operations are indivisible. The behavior of interrupts can be quite difficult to fully understand. Many catastrophic failures are caused by unexpected behaviors. Unfortunately, the logic of interrupt controllers is often described in poorly in processor documentation, leaving many possible behaviors unspecified. One way to make this logic more precise is to model it as an FSM, or finite state machine, like this one here. Interrupt mechanisms can be quite complex. Software that uses these mechanisms to provide input-output to an external device is called a device driver. Many failures in computer systems are caused by unexpected interactions between the device drivers and other programs, and writing a device driver that is correct and robust is a challenging engineering task, requiring a deep understanding of the architecture and considerable skill. Thank you for watching. Hopefully it has helped you gain a better understanding of the interrupts, and links to the sources and pictures will be in the description.